सर नमस्कार सर को सुबह जाऊँ ओके सर शुभ्रांशु सर हेलो हेलो सर को सुबह जाऊँ सर हमें स्टार्ट करेगा
Yes.
Good afternoon, everyone. I welcome you all to the second technical session of Day 6 of Smart Grid Technology 2022. Now we have with us Dr. Subhranshu Sekhar Das as the technical expert. Dr. Das is currently working as a professor and head of the Department of Electrical Engineering at Government College of Engineering, Keonjhar. He obtained his PhD degree from Anna University, Chennai in the year 2006, Masters from UC Bulla in 1996, and graduation degree from Institution of Engineers in the year 1994. He is having more than 27 years of teaching and research experience. He is a member of IEEE and Institute of Engineers and life member of ISTE. He is specialized in electric power systems with interest in smart grid, energy management, power system operation and control, AI techniques, and power converters. He has guided 35 PhD students and involved in consulting and research projects in India. He has published over 250 manuscripts in peer-reviewed journals and international conferences. He is a visiting scholar of La Havre University, France, and University of Wisconsin, USA, and visiting professor at Francois Rabelais University, Polytech, Tours, France, as well as La Havre University of France. He is the editor and reviewer of many international journals. He is an author to 3 books and published more than 20 chapters in Springer book series. He is the program chair of many international conferences. He has visited many countries like USA, UK, France, Spain, Singapore, Hong Kong for delivering guest lecture and chairing person session and presenting research paper and conducting international workshop from 2009 to 2019. He is an author of 3 books and published more than 20 chapters in Springer book series. So we are very much fortunate that Sir has given his consent for this technical session. Thank you so much, Sir. On behalf of Dreams Autonomous, I welcome you to this technical session.
Good morning, madam.
Good morning, sir.
Can I start?
Yes, sir. Yes, sir. Please.
So, happy New Year to all the participants, respected head of the departments, respected Professor Dr. Pradhan, sir, respected I think head of other departments, faculty members of various departments, participants. Very good morning to all of you. As I think, as I came to know that this FDP on the smart grid technology 2020, today is the 6th day. So I think in between this 5 days, last 5 days, participants may be attending lot of talk about these smart grids. So hope by this time they have some brief idea what the smart grids and how it works and what are the different components are there. So very important thing, I think at our test I must congratulate to the college, Dreams Engineering College, for selecting a right topic at the right times. As you know that at present, smart grid is having a lot of importance, and this smart grid technology, even though it has not implemented in India, it has started implementing in other countries like Australia and other Korea and USA. They're very much leading in this smart grid technology. So it is most essential, and as we are lagging, we have to find out how to implement in practical lives. So as I think all of you know that Indian installed capacity is coming around 3,90,000 megawatt we are producing electricity. So out of that, if you see, around 26% is renewable energy. So in this renewable energy, if you see, solar is I think almost 50% of renewable energy produced by solar. Next is wind. Next, biomass and small hydropowers. So why I'm talking about this one? Because I think I have given a topic. I'll be talking about role of renewable energy in the microgrid. So it is very important to know what the importance of renewable energy, why you should know it. Next is we'll talk about the microgrids. Before that, I will talk about the smart grids. So I think all of you, all the participants, they might have known so far what the importance of this smart grids. Am I right? Because we have been attending the class, you have been attending this FDV for last 5 days. So what is the importance of the smart grid and why it is so important? If you see a country like India, it is very, very important. You understand? And as per my knowledge, you are in the beginnings, there is a long way to go. You will see there are in India, you have basically in conventional grid, you have different approach. That is a top to bottom approach, but in smart grid approach is little bit different. You tell it is a bidirectional approach. Sorry. So you should tell it is a bidirectional approach. So where you can find out this participant role is very, very important. As customers, their role is very, very important. So in that constant, there is no doubt. This renewable energy plays very important roles as it is sustainable energy and is different from the conventional power plants. So I think all of you know about the Indian power scenario. So if we'll see basically that as far as solar is production is concerned, India is very fortunate to have the world's largest power plant is that. That is in Bhadla, that is in Rajasthan, where you can find out 10 million solar panels are there in the area of around 14,000 acres land, which is producing almost 2,245 megawatt. That's the largest solar plant. It is there in India. So India is doing a much more, because I still remember when I was in 2000, I think 11, I was in France. At the time I was working at SRM University. So when I talked about that is load shedding and power cutting in India, they started laughing. Because I was staying in a metro, and metros have a lot of electricity problems. But whereas they told in France or about Paris, they don't have any problem. Even in 5 minutes, you won't find any electricity shortage. You understand? There is no load shedding, there is no interruptions, all those things. And in foreign country, there are a lot of laws are there. If there is interruptions more than 2 minutes or 2 seconds, then you have to pay the penalties. So there is a lot of things are there where you have to pay the penalties, which is not so far implemented in India, because we are lagging behind the quality power. See, smart grid, what is going to do? What is the objectives? Get quality power with, if you see, we want to get a quality power with affordable cost, and power should be get from all the times. That smart grid, what are the objectives? Get quality power all the times with more efficient or low cost, which is not possible when you talk about the quality. You have to pay more. So India, we are suffering from the quality of power. That how to get it, that smart grid will be helping. You might have seen, you might have studied about different flash devices, different, if you see, compression devices, and different sensors, technology that has been used in the smart grid to make it more safer, more reliable, and you should get more robust the systems. So now if we go, now I think first of all I will already have told you what the smart grid, I think already you know it. So we will be talking about the renewable energy. Then I may talk about the DC microgrid, why it is important. Okay. So if we'll see about the DC microgrid in India, a lot of research is going on in IITs. In fact, I have met my friend who is in IIT Hyderabad, Dr. Siva Kumar. He is leading a project on DC microgrid. There is the idea that all this, whatever we are having, this distribution systems or in home appliances, all should be run in DC. So how it is possible, those things you will see. So now I can share some slides on, basically I will be talking about initially about talking about the PV, why it is important, why renewable energy is important. Then I will be talking about the DC microgrid, how this research can be done on this area. Is this slide is visible?
Yes, sir. Yes, sir. Visible, sir.
Okay, thank you. So opportunities and challenges of integrating renewable energy sources in smart grid systems. So as I told you, now much more talk is going on about the PV. So it is very important what I feel. 1 minute. Yeah. The slide is now clearly visible.
Yes, sir. Yes, sir. Visible, sir.
1 second. So just I will talk about the history of PV. As you know that in present scenario, PV plays very important role. So you must, if you'll see, you must know about this, how this PV has started, and lot of research is going on. If you'll see, I still remember when I was in Chennai for 30 years, wind energy has played a very important role. Now also total production of wind energy is around 40,000 megawatt, whereas solar has crossed the wind, it is around 50,000 megawatts. So this wind, if you see, earlier government used to give a lot of subscriptions and discounts for wind. Now it has come to solar. So solar, when you talk about, then PV is very important. So he started in 1767. A Swiss scientist named Horat Benedict de Sauer created the first solar collectors, that is an insulated box covered with 3 layers of glass to absorb the heat energy. Then after that, a French scientist in 1839, his name is Edmond Becquerel, discovered the photovoltaic effect in the year of 1839 while using 2 electrodes placed in an electrolyte. After exposing it to the lights, that electricity has been increased. Similarly, there is a lot of research from 1873 to 76. Then this first solar cell was introduced in 1883 later by Henry Hertz. In 1887, he discovered that ultraviolet ray has capacity to cause a spark jump between 2 electrodes. So 1891, the first solar heater was created. Then in 1908, William J. Bailey invented a copper collector which was constructed using copper coils and boxes. This collector had copper insulations. Then if you will see in 1967, a scientist known as Robert Milton evidenced the photoelectric effect experimentally, on which Albert Einstein has published a paper in 1905. Similarly, if you will see in 1977, the US government embraced the use of solar energy by launching the Solar Energy Research Institutes. Then 1981, solar powered aircraft was produced. Then 1986 to 1999, evolutions of large scale solar plants was there. The largest plant was developed by 1999, that is reached around 1000 megawatt, and more efficient solar cell was developed with a photovoltaic efficiency of 36%. So if you see, this past few years have seen enormous investment in utility scale solar plants. As of 2012, the largest solar energy plant is the Goldmore Solar Park in China. Now largest power plant I have told you in Badla in Rajasthan, which capacity is 2245 megawatt. So this is a wall PV scenario. So this is an Indian power scenario. Now it has crossed almost, as I told you, 50,000 megawatt. So this is India's largest PV plants. Now it has been changed to Batla in Rajasthan. Earlier it was in Amoda, that is next to the Madurai. So this solar panel, so if you do some research or something you want to buy, what parameters are required, that is very important to know it. So solar efficiency depends upon the parameters, depends upon the material you are using. Sorry. So these are specifications given, which is very important, is to know that what is the thickness, what is the length, what is the breadth. So to find out what is the maximum power, what is the open circuit voltage, what is the short circuit current, what is the maximum power voltage. So these parameters are essential when you design a solar panel. When you use a solar panel, these parameters will tell you for how much megawatt or how much watt, what much panel you should use. So this open circuit voltage, or you talk about short circuit current, these are very important for solar panel. So PV cell, if you are doing manufacturing, these materials are basically non-organic and organics. Non-organic materials are basically silicon, non-silicons, crystallines, thin films, and concentrated PV. Whereas if we'll see this may be monocrystallines, this may be amorphous silicons. So these materials are depend upon the efficiency. If it's a solar cell efficiency varies from 15-20%. If it's a material made from silicon, solar cell efficiencies, thin film solar cell efficiency have 9 to 12%, and dye sensitized solar cell efficiency is around 6 to 9%. So PV cell to RA, very important things. So nowadays very common. So if you see this is single crystals which is having 4.58 ampere to 26.5 volt, 80 mm. It is breadth. So these are the PV material given up different materials, single crystal and polycrystallines. So hierarchy of PV is, as I told you, one cell should produce 0.5 volt is to produce, and it has current of 5 to 6 amperes. When you go for a module nothing but combination of cell, it produced around 20 to 30 volt and ampere is 5 to 6 amperes. When you talk about array, it is around 200 to 300 volt and ampere is 50 ampere to 200 amperes. So these are specifications given because when you will install a solar panel, now the solar inverter is very popular. So these things are very much essential. Then from there you can find out how much area is required to install a solar power plants in our house. These are PV inverter architectures. So these PV inverters can be connected with the panels, can be connected with this module, can be connected with the array. You can see a string inverter architectures. Then there are different type of architecture. One is centralized, one is, you will see is this in this case detection on each string. Then there is a string PV arrays. So there are different type of inverters. Inverter can be put in each string, can be used as centralized solar inverters. Now these PV systems can be used as a standalone systems, can be used as a grid-tied systems, can be used as a hybrid systems. See, this is a very important thing is that what are the sources are there, how to find out short circuit voltage, how to find out open circuit voltage, short circuit current, how to find out peak power, maximum peak current, peak voltage. I still remember, you will see that in USA, basically in California states, there is a rule is that every state, every household should produce the 50% energy they consume. So if we will see in California states what happened, every household they have solar power plants. So daytime while they are working, they used to sell the power to the grid, and nighttime they used to take the power from the grids. Okay, so that is, as I told you, you can do net metering, and it is a bidirectional power transfer is happening. India, it may take a long way to do that once, but in many places they started you will see they started you can tell grid connected systems, or many places they started off grid, that is off gridded system they started. So this is the, if you see, very important is radiations. So as far as 1000 watt per meter square is there, you can see the current and voltage are high. When it is keep on decreasing, current and voltage are decreased. So this is the characteristic curves of PV module inferences for 1000 watt meter square, for 750 meter square and 500. So you can see here, very important temperature, based on temperature this is vary, based on that current and voltage are going to vary. This is isolations conditions for different things watt meter square. So this is a typical microgrid systems. So I am telling you, you can see I will be talking about the DC microgrid. This microgrid you will see they are having AC as well as DC. You see you have solar panel, you have wind generators, you have a fuel cell. So each source must have a converters, because when you connect to the grid, you must fed the fixed voltage and your frequency should be unique. So what I've done, you will see here in this microgrids, you have a PV panel, you have wind generators, you have fuel cell. So this DC is converted to DC, or AC is converted to DC, then you have a DC bus. So DC bus, then you have a 3-phase inverter which is converted DC to AC. Then due to harmonics, you have a LC filter, then you have bidirectional switch, then it connected to the grid. While connecting to the grid, you are connecting all in AC. So this is a microgrid. So I will be talking about, you might have heard in between, I think last 5 days, that about a smart grid and microgrid. Microgrid is part of the smart grid, but unless you don't have a resource, you don't consider it as a microgrid. Microgrid must have a own resource. Then you can tell it is a microgrid. It is very important things. Then when you talk about PV, there must be PV or wind. MPPT plays very important things because as I told you, you can see a lot of research is going on MPPT, that is maximum power point tracking technique. How do you get the maximum power point from the PV, from the source? So MPPT stands for maximum power point tracking, and each solar cell has a point R2 is the current and voltage output from the cell result in the maximum power output of the cell. So when you talk about maximum power from the PV cell, it is very important to get the maximum power from each and every cell. The MPPT algorithms are necessary in PV applications because the MPP of a solar panel varies with the irradiations and temperature. So the use of MPPT algorithms is required in order to obtain the maximum power from a solar array. The principle is that if the output from the cell can be regulated to the voltage and current levels needed to achieve a power output at this point, then the power generated by the solar cell will be used most efficiently. That is very important things. This is a block diagram of typical MPPT added PV systems. You can see here you have a solar panel, then you have a DC-DC converters, then you have a load, then this DC converters. What is going to do? It should give the maximum efficiency. How efficiency will be considered? Efficiency will be considered based on the duty cycle. The duty cycle can be get from the MPPT controllers. Now if we'll see what is the requirement for maximum power point tracking. Automatically find the voltage V maximum or current maximum at which a PV array should operate to obtain the maximum power output under a given temperature and irradiations. Maximum power point tracking, frequently referred to as MPPT, is an electronic system that operates the photovoltaic modules in a manner that allows the modules to produce all the power they are capable of. This is MPPT indispensable. You can see here we have taken for testing or put a load, whereas if you will see that cell is having 5.71 ampere and 17.5 volt, we have put a load and we have put a figures. So from this we will see irradiation is around 1000 watt meter square and rated load is given in case 1. Case 2 is 5000, or you can find out, you can see your voltage is more. Case 3 is 1000 and it is rated load with MPPT. So with MPPT you can see that is basically with the, that is 1000 watt meter square, you can see the voltage is more. When you talk about MPPT, that happens when voltage and current is more. That is, if you see, it is coming around at this point of 5 watt meters, maximum power point is given there. This is a flow chart and coding of P&O algorithms. I think might have come across these algorithms. When you do these maximum power points, these are conventional methods. Nowadays, a lot of you will see artificial intelligence has been used extremely to find out the best MPPT techniques. You have bacteria foraging, you have ant colony, you have shuffle frog algorithms, you have you will see you have genetic algorithms, but a lot of things are there. Basically, if you see, you have PSO, particle swarm obtention techniques. So there are a lot of techniques are there where it can be used to find out the maximum power point trackings. But this is P&O is a method which is a conventional method which is used to find out. Your algorithm is given clearly, as I am not going detail to these algorithms. If you want, I can explain you after this class, or I can give the slides. If you want, I can help you for these codings, all those things. This is a conventional methods to find out maximum power point from the PV cell. This is a PV curve of MPPT algorithms. Then comparison voltage reference MPPT, and there is another method is known as voltage reference MPPT. So if you see here, there is a term like FFD-MFA. That is, what is FFD-MF? That is feed. If you see, that will be feed forward derivative, the maximum fixations algorithm method. Okay, so in this case, that's a comparison is that between P&O and FFD-MF. It has found that in some cases FFD-MF has given better result than the P&O. These are another conventional methods. Okay. This is a comparison is given that some research class done some research between P and 1 FFDMF. Then this is experimental also verification has been done using DSPIC, this one. So in this case, it has been found out the proposed MPVT by different methods. They found out how to find out the MPVT. This is block diagram of cascaded multi-load inverter with feed forward, that is a direct maximum fixations algorithms. So the solar array is there. So this is one algorithm has been implemented to find out, basically to find out the MPVT use. So this is the multi-level inverters which enhance the performance of existing reduced switch topology, which is having higher harmonics and switching complexity by adapting slight modification has been done. This is, if you see, this is simulating model of PV fed 11 level inverters which has been used for this case study. This is a power circuit diagram of PV fed cascaded 11 level inverters. This is a control circuit of MPPT battery charging unit. This is an experimental setup for 11 level multi-level inverters. This is a pulses for 11 level multi-level inverters. So 11 level output voltage is given here. Harmonic spectrums are given versus square versus inverters. So now question is that if you see here, if you go to this one, you might have seen about the partial shading, correct? So if you see, you know very well what is the global search algorithms. So now if you talk about that, something like global and something like local. When you talk about a class, when some student is stopping the class, you tell it is a local. Am I right? When throughout India or throughout the world somebody stop, you tell it is a global. So there are some algorithms are there which may not suitable for global search algorithms. That may be suitable for only for local. They may stable at local maxima and minima points. So it is very important you should go for algorithms which is useful for partial shadings, that should be global search algorithms. So shading, you know, this due to that shading, whenever that is, if you see, we are not getting sunlight, PV panel is not getting light all the time. There is a shading is there. So how to avoid that one important thing. Then how to find out where it will get maximum power points. So what are the global searching methods are there? So basically most of the methods are all are artificial intelligence. So artificial intelligence, you know, there where you have expert, you will see you have the expert knowledge, or you have basically the fuzzy logics, you have, as I told you, there are a lot of evolutionary programs are there, genetic algorithm is there. So this artificial intelligence is very important to find out these are nothing but optimization techniques. See, our objective is what? To get maximum power. So for that you must use the optimization techniques. So there are a lot of, like as I told you, that is a frog shuffle algorithm is there. Okay, similarly I told you that the ant colony method is there, that's a PSO particle swarm optimization method. These methods are very useful because when you do for conventional methods, you don't get that much, if you see, that takes times, and that is very, that is very suitable for linear methods. For non-linear methods are basically can be solved by artificial intelligence methods. It may not be accurate, but it will give better result. See, there is a difference between, if you will see, conventional methods and artificial intelligence methods. So if you see in this case, you have irradiations is very important. Temperature as input is given to solar panels. Where you have PSO. So what is PSO? Particle swarm optimization methods. Or you have DE, that is a differential evolution algorithms. Or you have shuffle frog learning algorithms. These algorithms has been used. They are known as nothing but artificial intelligence algorithms that will give a duty cycles to the DC to DC converters. Then based on that DC to DC converter output will come. That is connected to the load. So our basic objective is your solar panel, whatever you are getting, that output should be maximums. That can help with the global source algorithms. So this is a homogeneous or inhomogeneous irradiations. Radiation may be homogeneous, may be inhomogeneous. This is multiple power peaks during shading. You can see here panel 1, panel 2, panel 3. all these panels may not be peak at one time, because one panel may be peak depend upon the shading. One panel may peak in some time, other panel may be peak in different time. So when panel is getting peak, by the time current will be high, you can find out power will be more. So this is given as different shading. Panel 1, 2, 3 is given case 1. Case 2, if you will see, this is also given panel 1, 2, 3. So this is all talk about. Now let us talk about the PSO, that is particle swarm optimization techniques, which is developed by Kennedy Eberhard in the year of 1995. This swarm intelligence is the collective behavior of decentralized self-organized systems inspired by biological behavior. This PSO method is a simple and effective meta-heuristic approach that can be applied to a multivariable functions operations having many local optimal points. Several cooperative agents are used, and each agent shares or exchanges information obtained in its respective and search process. Each agent moves with a velocity in a search space, and this movement depends on two factors: its own previous best positions and the previous best positions attained among all the agents. This is the computation technology. You can see here you have velocity and fitness. Then you have, will see you have the G best, you have the P best. So X positions and V velocity can you find out. Next you have inertia weight. This is the, if you will see, this is the our objective to find out G best as a global best, which gives the best fitness value. So what is the algorithm steps and what are you doing? First you are going, any method you do, initial method is that initializations. Particles are usually initialized randomly following uniform distributions over the search space, or are initialized on grid nodes that cover the search space with equidistant points. Step is fitness evaluations. Evaluate the fitness value of each particle. Fitness evaluation is conducted by supplying the candidate solution to the objective function. Step 3 is update individual and global based data. Individual and global based fitness values, P best, G best, and positions are updated by comparing the newly calculated fitness value. Then you have step 4 is your update velocity position of each particle. Step 5 is conversion determinations. This is a global peak power tracking with PSO algorithms. You can see here. This you can see here. There is some points like B1, B2, B3. Are they global best? No. You can see next diagram. G best is given in this because they are local maximum minimum point. B2 is maximum, but that is not global maximum. That is local maximum. Global maximum G best is given, which is the overall maximum. So it is very important when you do any methods, it may start with local maxima. You may not get the global maximum. So now a lot of research is going on how to get the global research, global maxima, what the methods are there, so that you can implement, you will get the global maxima. Then comparisons of peak power extracted through various MPPT techniques. You can see this is a P and O, then this is the PSO, this is a D, this is a SFLA. So these algorithms has been comparison of surf. If you will see, this is shuffle frog learning algorithms, differential evolutions algorithms, and PSO algorithms. That output has been compared, and it has been found that at the end that SFLA is given with less iterations, it has given better result, because peak power is given as 62.53, whereas other three methods are given 62 and 61 as well as 12. Input operating voltage also will see it has given more voltage, 8.168, and conversion time is less compared to PS1D. This is a comparison made by my research scholars. So in all, new MPPT algorithms for uniformly illuminated PV panel and AI-aided MPPT can be used during shaded and multi-peak issues. With respect to the work done in the research work, you will see two potential directions are suggested for the future research. Deployment of the robust control algorithms, that is known as sliding mode control, for tracking maximum power accurately in no time. So next part is coming. This you have seen this is nothing but diagram of a microgrid. So how to solve your critical load issue? Just 1 minute. Hello? Hello? Yes, sir. ଗୋଟେ 15 ମିନିଟ୍ ଟକ୍ ସରିବ ତାକୁ କହିବ ହେଲା ବାଏ okay we will see bye okay bye. Hello. Yeah, so if you see here you have a critical load issue. So here if you have wind generators, you have DC converter. This already have seen, this is nothing but a microgrid. So why critical load issue means, see, sometimes you must have backup. If you'll see in day-to-day life, hospital loads are very critical loads. That should supply for all the times. So that must be supplied from the battery. Battery supply should go to that you can see in these diagrams. Battery supply should supply from critical loads. So these are the critical load issues you can see here, as I told you. So this should be solved. You can see your DC battery should support the critical load. So this is hardware for that. This is a grid signals. I think now I can talk about, now I will go to the DC microgrid. So when we are just talking about the renewable energy, so when we, if you will see this renewable energy, when you are going to connect with the smart grids, is very important is the issues. What are the issues we will face? See, you might have seen this renewable energy having a lot of advantages. So can you put all this renewable energy to the smart grids? If you are going to put, what are the issues you are going to face it? That is very important to see. What are the issues are there when you connect so just now I completed about the PV, now I will talk about the wind, then I will be talking about the different issues related to these things. So as per you will see, this slide is visible.
Yes, sir.
Yeah.
Visual.
Just now I talked about the solar. Now if you see renewable power installed capacity is coming almost, it is I think 1 lakh megawatts. So if it's 100 gigawatts coming, so if you see here, now wind is coming around 40,000 there. So if you see in case of, if you see solar, very important is their temperature, because this solar, if you see, very important the source. Similarly, wind, very important is the speed of wind. You have caught in speed, you have caught out speed. So wind speed is very important. And if you see in this case, like you have a MPPT in the solar, similar MPPT is there in the wind. You can see from this slide, solar, similarly you have the MPPT, that is wind turbine power versus speed characteristics and maximum power point tracking. In this case, power in the wind turbine is given this formula, that is given as rho into A into Cp into B lambda B3. So basically here if you see, V is nothing but wind speed is very important in this case. So as wind varies, your if you see your voltage or output varies. In solar panel, you may think that when it is 100 degree temperature, so you may get more PV. That's not like that. They have a normal temperature. You will see by maximum at 25 degree. If you go beyond that, the saturation is that it may not, you may not get that much PV. Similarly, there is a caught-in speed, caught-out speed is there. You may think when the cyclone is there, understand that at the time wind speed is very high. but by that time actually wind towers are generally closed due to the safety. They may be broken. So there is a speed limit is there, cutoff speed is there. So if you see, this is the wind generation topology. It has different types. One is fixed speed, one is variable speed. So in this case, cannot track maximum power point. You will see in this case we have a gearbox. Generally for fixed speed, we are using a squirrel cage induction generator has been used. So you might have seen the wind towers in south. When I was there, I have seen a lot of wind power plants where a lot of small winds are connected. So each wind is also connected with the transformers, and if you see in this, and then will be connected to the grid. These are fixed speed wind turbines. So you will see this is a variable speed wind turbines. Now just I talk about this wind and solar. Then I will talk about when they connect to the grid, what are the problems they have been. Because it is not so easy to connect. You have a, if you see, you have a off-grid systems. You generate power and connect to the grid. Do you think it is quite easy? There is a lot of difficulties there, a lot of issues are there related to power qualities that I will discuss. So when we talk about the variable speed wind turbine generators, basically use the wound rotor synchronous generators or current magnet synchronous generators with gearbox, or you have direct drive synchronous generators. Similarly, you have the DFI is very common nowadays. Double fed induction generator is very common to use. So this is, if you see, this is the wind generators with gearbox where you are using a PMSG or WRVSG or SCIG. So if you see here, we are using a wind rotor induction generator is nothing but WRVSG. Okay, so in this case you can see this is the diagrams. So if you see, this is a given a generator with a gearbox. This is a coupling transfer connected to the grid. So basically, this, as I told you, speed is plays a very important role. Then this speed, what speed rotating, that may not be enough to the exciters of the generators to rotate. So you have a gearbox which increase the speed. Then if you see, after that you have a output is AC, you convert to DC. These are variable DC. Then variable DC should convert to fixed DC. Then you must get a AC. Then you have a low power filters is there to take the care of harmonics. These are double fed induction generators. Okay, this is very important things is that generally when you talk about wind, you have a two type of turbines are there. One is horizontal axis, one is vertical axis. So most of the case you are using, if you see, you are using the horizontal axis turbines. So in this case, if you see, this DFIG is a lot of business is going on basically in the DFIGs, and how to get the maximum power point in this case. What should the design of the inverters? That's very important things because it's two phase. These are direct drive permanent magnet signal generators used to connect to the grid. This is already I have talked about smart grids, where if you see smart grid plus IT will give the smart grids. So what are the attributes of smart grids? Already it has been told, I think, by the previous speakers about reduction in electricity, assuming power quality. So why I am talking this one? Power quality is very important in this case. Now questions coming, when you integrate grid, when you do the integration of wind to the grid, what are the difficulties you will face? See, I have a solar power plant. Can I connect to the grid directly? These questions arise. But if you know that wind speed is vary from time to time, when wind speeds vary, there is a fluctuation of the voltage. When there is a fluctuation of voltage, when you connect to the grid directly, there may be some problems. So that must be look after those issues. Wind flow always varies and depends on weather conditions. Because of this grid, integration of wind energy conversion systems can affect the power system negatively. This intermittent and diffuse nature of wind power introduces new factors of uncertainty on the power system operation. Technical challenge with the integration of large wind farms to the grid, that is impact on system securities. Basically, that the impact will that you will have a power imbalance, you have impact on reserve management, you have impact on power system voltage, impact on power qualities. That is basically you can see there may be a chance of harmonics. You know that harmonics are happen due to nonlinear loads. When nonlinear loads are there is more possibilities that harmonics will happen, and due to fluctuation in the voltage, you may have flickers, you may have voltage dip. So that's why you used to use a lot of composite devices like DStatCom, UPQCR have been used when there is a wind energy. Impact on power system stability, then you have a transmissions planning. So what is the impact on system securities due to this wind energy? So basically, the security of systems means ability to contribute to both frequency and voltage control in stabilizing a system following a disturbance. When there is a disturbance, security should be, it will be stable. They must be able to ramp up or ramp down. They must be able to ride through disturbances. They should be able to operate in islanded mode when supply from grid is lost. Then islanded operations means islanded operations will change the power flow. Maintaining a power balance is required after islanded operations. This is microgrid connected to the grid. This is also microgrid. As I told you, microgrid is nothing but part of the smart grids, but it must have its own source. So here you have wind, PV, and storage that connected to, if it's that connected to load, and it has to be connected to the grid. It may be a microgrid, may be a, if you see, may be connected to the grid, may not be connected to the grids. Impact on operating cost due to power imbalance. The system must maintain a balance between the aggregated demand and total power generated by all power plants feeding the systems. Wind speed cannot be predicted with high accuracy. Consequently, utility planners and operators are concerned about the variations in the wind outputs. So, conventional power plants require to deviate from operating points that are chosen to minimize total cost of operating the entire system. A penalty cost is often attached to the deviations in the scheduled and actual energy to the grids. This may increase the operating cost of the systems. Impact of wind power on reserve management. A system of high wind power implications would expand the reserve capacity due to variability of primary sources. Mostly conventional power plants are expected to provide for these variabilities. Due to more variable nature, it has effect on both the operational cost and ancillary services cost of the system. An extra reserve of 3 to 6% of the rated capacity of wind plant is required in a 10% wind integrations and 4 to 8% is approximately for 20% wind integrations. So impact on power system voltage, this is very important, as we are all, if you see electrical engineers, it's very important to understand the voltage, power system voltage control. What is the impact? The nodal voltage distribution on the power system network must be within the acceptable limits. You know that there is a voltage limit is there. The reactive power contributions capability of a power plant determines its nodal voltage control. As you know that if you want to control the voltage, it's very important to have knowledge about the reactive powers. Because reactive power, whatever you are supplying or whatever you are generating, based on that, your voltage control will be done. Basically, if you see what I am talking about, the compensating devices like D-STATCOM or UPQC, or you talk about DVR. So these devices are connected in series or SON to maintain the voltage control. So how it has been worked? What is the logic behind it? How it is working? That is very important. You know that in case of DVR, what we are doing, it's connected in series. So it generate or absorb reactive power based on the demands. You understand? When you are injecting, if you see one in the injecting a current, so what happened there is when you are injecting a current, you must, when you connect in series, you are injecting current or injecting voltage. What you find out in case of series connections, you are injecting a voltage. That voltage and your line current, there may be a phase difference. That phase difference will tell you whether you need a reactive power or you need a inductive power. You understand? So when it leads, it supplies reactive power. When it is lacks, it absorbs reactive powers. So reactive power control is very, very important. And in case, this is basically important when there is a wind energy, because as you know that wind energy case, there may be a change in the voltage profile due to speed change. When there is change in voltage profile, to maintain the constant voltage, it is very important we must generate the reactive powers. So to generate reactive powers, as you know that when you talk about this, as these circuits have uh, lot of people see non-linear devices, so it also creates a lot of harmonics. To suppress the harmonics, to have better quality power, you have to use some compensating devices so that it has the filters inside. It can harmonics can be avoided or can be eliminated, and secondly it can also give the rated voltage. In that way, this reactive power control is very important. So most wind energy conversion systems make use of induction generators, which are not capable of injecting reactive power to the grids. Impact on partial voltage control, variation in steady state voltage. The relationship between the voltage gradient and flow of active and reactive power on the radial distributors can be expressed del V equal to Rp plus or minus SQ by V, whereas you will see R is reactive power generations, reactive power absorptions, minus means observations, Rx is the feeder resistance and reactance, PQ is active and reactive power. In case of transmission lines, X by R ratio is significantly more, however in the distribution lines it is very less. Because if you see, if you talk about long transmission lines, X is much more than R. In short transmission lines, you will see your X is little bit less. So it can be said that active power has major effect on voltage profile in case of distribution systems. Whereas reactive power transfer is a dominant factor in case of transmission systems. As I told you, when you talk about transmission systems, their voltage is very high. Their reactive power transfer is plays very important. When you talk about distribution systems where it is you are handling low voltage, there may be a active power may play the important role. So these are the active power flow you can see here, where current and these are in same lines. There is no reactance. Second case you have a reactance. Third case you have a if you will see you have this one. You have a reactance, reactive power load. So this is given that how it has been absorbed and how it has been supplied. So now few examples it is given that large wind farms say 400 megawatts connected to 275 kilowatt networks. The network impedance is relatively reactive. This allows the exchange of large amount of active power with a relatively little voltage drop and low losses. However, exchange of reactive power between grid and wind farm affects the voltage. When there is exchange of reactive power between grid and wind farm, definitely affect the voltage. The large wind farm connected to 130 or 33 kV nodes. Network voltage requirement need to be more stringent if the loads are also connected electrically close to the wind farm. In case of connection to 33 kV system, the worry will be that voltage will fluctuate wildly. Generous embedded distribution in distribution networks, design voltage profile without embedded generations, voltage profile with voltage regulators, voltage profile with tail end embedded systems. So voltage variation during transients. So basically low voltage, this happens because of fault on transmission lines. Severe grid disturbance such as huge voltage dip caused by short circuit faults can lead to generating units disconnected from the grid. This may cause instability in the grid. According to new generation code, wind turbine generators must stay connected for the fault. They must be stable throughout. This is given crowbar for protections and fault right through capability of double fed induction generators is given. Fault right through capability of PMSC permanent magnetic signal generator through chopper in DC bars. Impact on power system voltage control. Fault right through requirements is given. It may disconnect. Must remain connected is given the diagrams. Impact on power system voltage and high voltage. Under certain conditions, wind generators are required to isolate from rest of grid called as island operations. In such cases, the windmills have to brake and trip automatically. This, however, cannot happen instantaneously and windmills will continue to provide active power. This may cause overvoltage risks and unacceptable value of frequency. Impact of wind power on power quality. This is very important point. Deviations from nominal sinusoidal voltage of current waveforms in power system networks determine the quality of power transmitted on grid. ନା ତା ଆଗରୁ ଆସିଲା ଆପଣ ଦେଖନ୍ତୁ ଗୋଟେ ମିଟିଂ ଟପ୍ ଅଛି ବୋଲେ ଟପ୍ ଅଛି ଆପଣ କହୁଥିଲା ମୋର ଟପ୍ ଅଛି ମୋର ଏଭ୍ରି ଟପ୍ ଅଛି ହେଲା So these deviations from nominal sanctuary voltage or current of farming power network determine the quality of power transmission grid. So basically they will create harmonic distortions, flickers, voltage imbalance, voltage sag and voltage swell. The level of tolerance of power quality depends on the kind of load installed by the customers. That is how sensitive the load is there. The poor power quality could lead to losses on the grid, malfunctioning of the electrical equipments, and even a loss of synchronism that could lead to the network failures. So very important is power quality. So as you know that how it can be maintained, why you are debating from the power qualities. You see, basically in India you need a 24/7 power, but you are least bothered about the power qualities. So these power quality problems are arised due to the non-linear devices, due to the certain loads. You know that theft. In India, if you see, ATC losses are commercial, the transmission losses are coming around 30%. Some states, they have, like Jammu Kashmir and Bihar, they have more than 50%. Some states are less. If you see Tamil Nadu, they are having around 20%. So these TNC losses are so high. Why these losses are high and what is the impact? When the losses are very high, these transmission losses are very high. What happened actually? You will see you cannot maintain quality. See, power generation is around, I told you 4 lakhs megawatt. But power reaching to the customers are, if you see losses are 30%, there is 30% power lost in the transmission lines. Then 30% loss means around, if you see around 1 lakh power lost in the transmission lines. When that much power is lost, so definitely efficiency and quality is definitely degrading because there is always mismatch between demand and supply. Demand and supply never match with each other. You see always, if you see always demand is, if you see, more than supply. So what happened in that case? Can you maintain the quality? See, you have a transformer for a specific loads. For next 5 years, even the customers are increased, loads are increased, but power supply to the transformer is same. So in that case, how do you manage the power management? There smart grid plays important role. You have a smart grid. So what you do? You have to use the smart meters. You have to use the AMI, that is advanced meter infrastructures. So what happens? That will collect the data from the customers. What the need of power? What the demand of power from the customers? When you need the demand of power from the customers, then you can assess what the supply is there. You understand? Then there may be a matching between them. If there is no matching is there, you are getting same power and loads are increased, definitely it will deviate the quality. Power quality is very important issues. So what will happen, as I told you, you will have a voltage dip, you may have a power imbalance, you may have a sag, you may have a swell, you have a transients, you have impulsive transients, you have a harmonics. So these problems are coming due to the basically when you transmit a power from long distance, these problems will come. To sort out these problems, actually you will be depending upon the smart grids. So what we will do, since power transfer from a long network, losses are more, you are going to generate a power that may be role of DG, distributed generations. You are going to generate a power in the very close to the load centers. When you generate power very close to the load centers, so what will happen in that case? When you generate a power very close to load centers, in that case losses will minimum, but those DGs are basically renewable energy. When you talk about they are basically renewable energy, so when you integrate this one to the system, these are the additional problems may happen. Okay, due to they are depending upon speed or depending upon the solar irradiations. So it is not constant all the times. So to avoid those things, as I told you, you can use lot of compensating devices. That is very important to use. So level of tolerance of power cut depends on the kind of load installed by the customers. That is how sensitive the load is. That see, harmonies. Why it happened? When our loads are non-linear loads, harmonies has come to the pictures. When our loads is you have a arcing or welders, then this type of 1 minute.
Sir, is there any more or we will conclude, sir?
I don't know how to go to that slides presentations. Okay, there is some problem is there this time. Yeah, is it visible now? Hello? Is it visible? Okay, sorry. So just I'll talk about DC microgrid. Impact of wind power on power quality is very important. As I told you, how harmonics are generated. At generation level, sources of harmonics, as I told you, facts is very important devices. Power devices and facts inject the harmonic systems. Others include adjustable speed drives, generator, speed controls, HVDC installations. They could cause distortions. Harmonics increase line losses and cause excessive heating of equipments, which decrease their lifelines. Then impact of wind power grid voltage dip could occur when there is a large load such as motor startup, transformer energizing, capacitor energizing, momentum overload. Then voltage dip is considered as a drop in power voltage to a level of below 90% of the normal voltage. Sorry. Then if you see, due to this effect, basically equipments are getting damaged. So then if you see about the power system stability is very important and very big area. So this is, even though variable speed wind turbines do not contribute to the system's inertia, the inertia can be using additional control lobes. So primary frequency support by wind turbines can be achieved by following methods using deloaded operations. In deloaded operations of wind methods is basically shifting wind turbine generators operating point from maximum power point to the reduced power, thus creating some reserve. This is given in this figure. So this there is inertial response in converter control is given. Then if we see, I think there is time shortage. The next is transmission plannings. Wind turbines are of course mainly installed in places with good wind resources. This can lead to high concentration of wind power in some regions. This means that large amount of wind power will be generated in regions where the local consumption is low and excess has to be exported. In order to that, it is necessary to have a strong transmission grid designed for the transfer of wind powers. So mitigation strategy for wind energy conversion systems integrations. This is an acceptable integration level of wind power has not been definite. No particular definition has been given so far. However, by adopting and improving the various mitigating strategies, some of the integration challenges can be alleviated and higher integrations level can be achieved. Those strategies are that geographical locations, use of smart grids. That's why I told you, in smart grid is very important because you have a lot of sensors, lot of advanced computer technology, you have a lot of filters, and you have a lot of you will see like composite devices are there which can mitigate the problem created by the renewable energies. Improved energy storage technology, that is you are lagging, improved wind forecasting techniques and use of fact devices, that can the solutions. Geographical location is the correlation between the fluctuating primary resources of different sites. It decreases with the distance between sites. See, as I told you, load area and this source area, if distance is less, then your problem will be fluctuating or other problem will be less. This is given as study also reviewed that 10 or more geographical separated wind farms connected together have a reliability of about 33 to 47% of their average output compared to a concentrated located wind farms. Use of smart grids, this already I've been talking for a long time. Very important is smart grids, as you know, that is the information and communication technology based network that would allow bidirectional flow of power and informations. It allows the transmission of wind power from a site of favorable generation to places of high demand power. Then use of improved energy storage technologies, use of electric vehicles. Nowadays, if you see, government has announced a lot of beneficiary for electric vehicles. And there is also PHEV, you know that one, plug-in hybrid electric vehicles. Then there is V2G, vehicle to grid. See, nowadays, this vehicle to grid, electric vehicles or your plug-in hybrid electric vehicles, they can act as a source, they can store electricity. In night, they can supply for a essential or critical loads. That is very important things because you are lagging so much on the resources. Basically, storage is the biggest problem. See, you generate more power during, you can talk about winter, if you see supply, demand is less, but supply is more. So there is a lot of things. If you are able to store it, understand? Daytime, if you are able to store the solar power, night time it can be used. So storage plays a very important role. That a lot of things are talk is going on how to use this PHEV and B2Gs effectively so that power can be stored with that help. Use of fax devices, already I have told you, SVC, STATCOM or AAAC can be used so that this they can supply reactive powers, they can supply even real powers. That is very important things. Then you have example low voltage fault right through STATCOMs. STATCOM is, if you will see, this is for transmission lines. When you talk about distribution lines, you have a D-STATCOMs. Okay, this plays a very important role for basically for voltage control. So these are given some reference. Now we'll go about the power management DC microgrid. So as I told you, microgrids are low voltage distribution systems containing loads, distributed generation, storage devices or controllable loads that can be operated in a controlled, coordinated way, either in grid connected or standalone mode. Microgrids can be AC or DC depending on the connections of sources and loads to the common buses. Extensive research work has been carried out in the last few decades for smooth operations, control and operation of AC microgrids operating either in grid connected or island mode. In recent years, a DC microgrid system has attracted increasing popularity over AC microgrid due to the numerous advantages. So AC versus DC microgrid always talk is going on. The DC microgrid is more reliable and has higher overall efficiency and low maintenance cost due to the requirement of the single stage converters compared to two stage conversion in AC microgrid. The DC distribution systems, so the DC microgrid does not face any grid signals control issue, neither have needed grid side frequencies. There is some problem in the So operational challenge of DC microgrids. The DC microgrid has following major operational challenges needs to be taken care for its smooth operations. Optimal power sharing among different renewable sources connected to DC bus during system contingencies. DC link voltage control within the permissible limits, that is 5% during system contingencies. Power management, stabilities or fault tolerance, design of suitable converters in DC microgrid. This is a generalized structure of DC microgrids. Already we have seen you have sources like PV cell, wind turbines, then you have fuel cells, batteries, electrolyzer that is connected, that will be DC grids. Okay, these all may produce AC or DC. Finally, it should convert, all should come to DC. Then you have DC microgrids. Then you have a controller. Then you can go to DC loads. This is the general structure of DC microgrids. So several methods are available in the literature for DC link voltage control and power management DC microgrid. Performance of most of the schemes are evaluated considering limited varieties of renewable energy sources and energy storage devices operated either in grid connected or island board. The non-deterministic characteristics of renewable sources and loads in standalone DC microgrid difficulty in achieving the power in balance. That's very important thing. So if you see, there will a study has been done by DC microgrid, which has been there have been a, if you see Tagani Sugana physiology has been used for DC to stabilize the DC microgrids. Wherever you have different controller is there, this is a DC microgrid. There are different mechanism has been used to, if you will see, to manage the power. How to manage it by using the physiology. This is a different area. Yes. So I think as you will see, there is a lot of advantages are there, but still then we are not implemented properly. This is some of the research done by one of the research scholars. So I think I have a validity function. So this is a lot of research is going on in DC microgrids. 1 minute. Whatever.
ସତେଇଶ ପାଖରୁ ସାର୍ ଚିକେନ୍ ପକ୍ସ ବାହାରିଥିଲା ସାର୍ 27ରୁ ଆଜି ପର୍ଯ୍ୟନ୍ତ ସାର୍ ଆବସେନ୍ସ ଥିଲି ତ ଏବେ ସାର୍ କହିଲେ କି ଆଉ ତମେ ଏଚଡି ସାର୍ ଆଉ କୁହ କି
Okay, give that letter to him. Give the letter to him. Okay, I will meet him. Okay, I'll talk to him. So sorry for disturbance. So I think there is one more meeting is there by 1:15. So this, if you see, just human beings shall take it. There is a lot of what I am going to tell you. There is a lot of research work is going on in this area. So my focus is, as you are teachers and you are researchers, there is no end in doing research. So very important thing, this FDV should encourage the young faculty members. Those have not done research, they can do research. Those are doing research also, they should keep on doing research. Because this smart is very important subjects. It's a very wide area. In fact, I remember when in 2013 I was in USA, I was doing a project on microgrids. There are students from different streams they have joined. They are from EC, they are from civil students. Generally, their objective is to install this wind towers, and there are mechanical students who are designing the blades. There are chemical students who are working in the battery sides, and electrical students have the important role to have this voltage control, all those things. So this smart grid has very wide range, very wide applications. It is not only related to the electrical departments. What I have seen, if you see in this case, that is cyber attack is that if you talk about smart meters or you talk about information technology, very important thing. See, you don't use IT to the smart grid or to the grid, then it cannot be a smart grid. IT also plays very important role. You talk about communication technology, 5G, 4G, these things are very part of the smart grids. IoT, they are all part of the smart grid. It is a very wide area. So a lot of things are there. This I hope these 6 days FDBs might have given a lot of things and information about the smart grids. But in my knowledge, this is the beginnings. You have to study a lot and you have to go to details thoroughly, because in this limited time, if you will see, we cannot be masters, but you can get some idea about the different work going on throughout India and world, so that you can be involved in that case. That is my idea, to give a knowledge in the area of PV, in the area of wind, and what are difficulties area there, so that this is a research area where you can do the research and you can keep or you can, if you see, progress our research to the further stage. So with this, I think I am now concluding my talks. So I must thank to the organizer for giving this opportunity. I must thank to the management of DRIEMS Engineering College for giving the opportunity. I thank to the Dr. Pradhan professor who has given these opportunities. It is a nice thing, and I must thank to the audience Any program without audience, it cannot be success, it cannot be done. So audience has a lot of important role in this case because they have been attending this program for 6 days. You know, when you conduct offline, there is a lot of difference between online, because while I'm talking or something like that, it is always offline is very interesting, and offline is difficult for participants as well as for the audience. But I must thanks to the organizers who has taken so much effort to have this FDB in the offline modes, as you are facing all COVID and pandemic situations. Organizing in offline, organizing this FDB in online mode also too difficult. You know, organizing and having speakers and a lot of things are there. So thanks to the organizer for organizing this conference. Thanks to all. Thank you, sir.
Thank you, sir. Any question from our participants? Any question, please, from our participant side?
Yeah, if there are any questions, or you can also contact me. After this talk, I will be always with the participants. If they want any, they want to contact me, they can contact me. Okay, my mail ID is already there. I think I will request the organizer. They can give my mail IDs. They can send a mail or they can call me. If they have anything
Yes,
to
sir.
help in the research, I
Will
will
give.
be happy to help them.
Okay, sir. Sir, thank you, sir. Thank you, all the participants.
Yeah. Thank you, sir. Thanks.
On behalf of department, I would like to extend my most sincere thanks to Almighty for His blessings and making today's event a resounding success. On behalf of FDBT committee, I extend my heartfelt thanks to our revered speaker, Professor Dr. Subran Kumar Das, sir, of Government College of Engineering, Keonjhar. Thank you, sir, for your beautiful lecture. Thank you a lot, sir, for accepting our invitation and presented elaborately about the theme topic and enlightened to all our participants through your beautiful presentation. And as per the feedback from our participants, the whole session was excellent and informative one, and we have no word to express. Thank you, sir, for your joining and kind association, and expecting more sessions in near future.
Thank you, sir. Thank you.
Thank you, sir. Now it's time of felicitation to our esteemed speaker of the session. Now may I request our coordinator, please share the screen of felicitation.
Thank you, sir.
Thank you, sir.
Thank you.
Thanks to our coordinator, student coordinator, Saurabh, Aditya for technical support. Thanks to coordinator, co-coordinator, and all organizing committee members for successfully organizing the session. And thanks to all the faculty participants for joining and patient sharing. Thank you and thank you all. And participants are requested to fill up the feedback link followed by the quick test. Again, we have a validity section at 2:30 p.m. sharp. Please, all of you are requested to join sharp at 2:30 p.m. Thank you all.
Dear participants, again we will meet at 2:30 p.m. for validatory session. Kindly join in that session. Then it will be over. FDP will be over. Thank you.